Okay, problem number 21. What is the area of the region on the coordinate plane that is bounded by 4 lines? The first line is given by equation x plus y equals 2. The second line is y minus x equals 2. And the third line is 2x minus y is 4. The fourth one is 2x plus y equals -4. Let's draw these 4 lines on the coordinate plane. So here's x, and this is y. The first one, x plus y equals 2. The way we draw a line, one efficient way is you just need to decide what is the y-intercept and what's the x-intercept. So for this one, it's just 2, 2. So this is x plus y equals 2. And then we have x minus y is 2. That's right here. So x is -2. The x-intercept is -2. The y-intercept is still 2. And then we draw the line 2x minus y is 4. The x-intercept is 2. The y-intercept is -4, right? Okay, so this is 2x minus y is 4. Here's y minus x is 2. The last one, 2x plus y is -4. The x-intercept is -2, and the y-intercept again is -4. It's right here. So we just connect these 2 points. So this line is described by 2x plus y is -4. All right. Then we just need to calculate the area of this region bounded by these 4 lines. Clearly, it's just the 2 triangles. Here the height is 2, this is 2, and this is 4, so it's 6, right? So the area equals twice, right? It's 2 copies of a triangle times the height, that's 2, times the base, that's 6, right? 2 plus 4, that's 6, so this is 6, and then divided by 2, so 2 cancel with 2, what you have is 12. Okay, now let's look at the problem number 22. The problem says we have a special 3-digit number n. It satisfies the following 3 things. Number 1, all digits are different. Number 2, when n is divided by 7, the remainder is 4. Number 3, if we switch the unit and 100 digits of n, the new number, when divided by 7, the remainder is still 4. Right? We need to find the least such 3-digit number. To solve this problem, we need some algebra. Solution, I put n as a, b, c. So a, b, c represent 3 digits of n. When divided by 7, the remainder is 4. Now, if we switch the unit digit and the hundredths digit, then we get a c, b, a, right? We just switch them. All right, so CBA, this new number, when divided by 7, the remainder is also 4. Now, because they have the same remainder when divided by 7, therefore, if I take the difference between these two, I should get a number that is divisible by 7. From here, I get if ABC minus CBA divided by 7, the remainder is 0, right? It's 4 minus 4 is 0. Therefore, this just means it's divisible by 7. Let's write this one out. ABC, so ABC, this equals 100A plus 10B plus C. So this is for ABC. And the other one equals 100C plus 10B plus A. Now we take the difference of these two. Immediately we see 10B, they cancel with each other. Now we combine like terms of A and C, we get this equals, it's 9090A minus 9090C, and this one is divisible by 7, okay? From here, we just get the 99 times A minus C is divisible by 7, because 99 and 7 is relative prime. From here, I get A minus C has to be divisible by 7. Then, because since we are looking for the least A, B, C. A natural choice from here, I just gonna choose A to be 1 and C is 8. Okay? And then A minus C is -7. Then of course, it's divisible by 7. All right. Now I put this back, my N. I get my N equals 1. And then we have B, and this is 8. Okay. For this number, I want this number to be to have a remainder 4 when it's divided by 7. Here, what we left is to decide what shall be the B, right? Okay. Now here, we cannot take A to be 1 and C to be 1. That's because we require all 3 digits to be different. All right. Now, from here, we just get because we just get 1 B8 minus 4. This one has to be divisible by 7. I just minus remainder, and this equals 1B4. This one has to be divisible by 7. So in other words, 1B4. So this one is the B. That's what we need to decide. So 1B4 has to be equals 7 times a 2-digit number. The point is, when you look at the last digit 4, in order to get a 4, we can only have 7 times 2, right? 7 times 2 will give us the last digit 4. That's basically only possible. Therefore, here I should put is 2. Okay, I get it. This is 2. You must have this is 2. Also, since this is 3-digit, what I can put here is 2, right? I just make it 2. So that's I get this is 2. All right. This tells me the quotient has to be 22. Now let's me calculate the 22. That's 154, and we get this B. The B is 5. Okay, combine all those information together. We put it back to the B, so we get N. The N equals 158, and the sum of digits equals 1 plus 5 plus 8, that's 14. So here, the main point is we use algebra. We use ABC to denote 3 digits of N, and then we switch the, like here, we switch the unit digit and 100 digit. And then because they have the same remainder, so when we divide them, so when we take the difference, has to be divisible by 7, and this reduced to the requirement A minus C is divisible by 7. But we are looking for, of course, there are many choices just to make A minus C to be divisible by 7. But here we are looking for the least one is A is 1 and C is 8. Now C cannot be 1 because we require things to be different. Okay, right? And then we just go back to here, keep doing to find what are the BAs. Problem number 23. Here we have a quadratic equation. So the right-hand side and left-hand side both are quadratic functions. We need to find the largest possible value B so that this one has a real number solution. What do we do? Let's write it out. So for both sides, let's write it out. We have x minus 2 squared. Let's recall. So a plus b squared equals a squared plus 2ab and plus b squared. And if you change b to minus, that's a minus b squared. It's a squared minus 2ab and plus b squared. Let's apply this identity. Then we get this one equals x squared minus 4x and then plus 4. Similarly, 2x minus 1 squared, this equals 2x squared minus 4x and plus 1. So that's 4x squared minus 4x plus 1. Let's set up the equation. Let's plug this 2 into here and that one into there. We get x squared minus 4x plus 4 equals 4x squared minus 4x plus 1, and then plus the b, right? Plus the b. Let's simplify the thing. Minus 4x, they just cancel with each other. And I can move x squared to the right-hand side, right? So then we just get the b the 4 minus, and then we move the b to the other side, we get the 4, and there's 1 here. There's also 1 here. So 4, so I get it's 4 minus 1, and then minus b equals 4x squared minus x squared. So that's 3x squared, right? And this is 3 minus b equals 3x squared. The point is, in order for this one to have at least one solution, the right-hand side, if you look at the left-hand side, this left-hand side has to be no less than 0, since the right-hand side is 3 times x squared. From here, we derive the b has to be less or equivalent to 3. And therefore, 3 is the largest possible value so that this equation has a solution. And also, we easy to notice if b is 3, we just get x is 0. Problem number 24. Here we have a trapezoid ABCD. We know the ratio of AB to CD. This is 1, 3. And E is a point on AD that bisects the area of ABCD. Now, if we connect the CE extend to a point that intersects AB at F. We also know the area of this triangle AEF is 1. The question is, what is the area of ABCD? Solution. To solve this problem, we need to add a helping line. Let's connect AC. We connect the point AC and look at the triangle ABC. The point is, if you look at ADC and CAB, they have the same height. If I choose AB as the base, they have the height is the same because it's because AB and CD, they are parallel. And from here, we derive in areas, the triangle ABC over the triangle ADC equals AB over CD, which is 1 over 3. Meanwhile, we also have, so that's the first one. And second one, we also know the area of ABC plus the area of AEC is the same as the area of DEC. That's just because it bisects the CE bisects the trapezoid ABCD. Therefore, if I put this one as say this is X and this is Y, then CDE, the area will be 3X minus Y, right? If this one is X, then this is a 3X. This is X. This one will just be AEC, this is Y, okay? And this one will be 3X minus Y, right? Okay, all right. And then we know X plus Y is 3X minus Y. From here, we quickly get Y is the same as X. All right, so I can replace the Y just by X. From here, we just get a Y is the same as X, so I can put X here. This part will be just 2X. Now, the point is, after I know the area, I get the ratio of, in areas, the ratio of AEC over the area of DEC. This is the same as the ratio of their base AE and ED because they share the same height. So here we get is just AE over ED. The ratio of this we already have. That's just 1 over 2. Okay, so I get this to that is 1, 2. And now let's use the fact we have this triangle is similar to, right? So we have the triangle AEF is similar to a triangle EDC. The ratio is 1, the side of the ratio is 1, is 1 to 2. And then we know the area. If the ratio between sides is 1 to 2, then the ratio between the area, you have to take the square, okay? So if this is 1, so I get, from here I derive the area of AEF over the area of DEC. This one equals 1 over 2 squared, it's 1 over 4. Therefore, this one is 1, and then this one will be 4. This is 1, this is 4. Now, if DEC is 4, since CE bisects the area of ABCD, I get the up half is also 4. So 4 plus 4 is 8. 4 plus 4, the area is 8. If we quickly review the solution of this problem, 2 key points. Number 1, so this is the first one. Because triangle ABC, and ADC, they have the same height. The number of height is the same. The ratio between the areas is just the ratio between AB over CD. And then combine with the fact the CE bisects the ABCD, will get this AC separates ABCD into areas X, X, and 2X. And this allows us to find the ratio between AE and ED. And then we just use similar triangles to find the ratio between areas. Problem number 25. Here we have 7 numbers, 1, 2, 3, 4, 5, 6. There's a box in front of each of these 7 numbers. What we do is randomly assign plus or minus to the following boxes, right? So it's plus, minus, plus, minus, plus or minus. The question is, what is the probability the resulting number after you assign plus or minus is divisible by 3? Let's simplify the problem. So let's do some simplification. Here, notice 3 and 6, they are divisible by 3. That means regardless you put a plus or minus, it's not going to change whether the final result is divisible by 3 or not. Therefore, as a first step of simplification, we can just get rid of, we can just forget about 3 and 6. We only need to focus on the remaining 5 numbers. We'll just look at. So just look at. Okay, so remove 3 and 6. So we have 1, 2, 4, 5, and 7. 5 boxes in front of them. The problem is equivalent to saying we have 5 numbers, 1, 2, 4, 5, 7, and randomly assign plus or minus in front of 8. What is the probability the resulting number is divisible by 3? Okay. Let's do another simplification just by remainders, using remainders divided by 3. Because we only care about whether it's divisible by 3 or not, right? So that means for each number, the only thing matters is the remainder. So let's look at the remainder. This is just 1. 2, I use -1. I just go to a -1. Just for convenience. This is a common trick if we want to consider remainders. We sometimes use a negative because it's smaller. If you take relatively smaller, right? -1. Okay. Then 4 is 1, 5 is 2, and 7 is 1, but 2, we can also put it to be -1, right? So 4 to 1, 5 to 2, 7 to 1. 2, as I said, we can put this one is also -1. From here, we have 2 ways to proceed. Method 1, we just go straightforward. In order, you see, if I put a plus or minus in front of 1, -1, in order, like 5 of them, in order to make it divisible by 3, there are only 2 cases. Case 1, we'll get it's 3, right? Or case 2, we'll get is -3. These 2 cases are symmetric. If you get 1, 3, then you just switch the sign, you get -3, right? How you get 3, you can only have like 1 plus 1 plus 1. then +1 and -1. And -3 is -1, -1, -1, -1, and +1. And then it's not hard to check. You have there are 5 different ways to arrange that. And by symmetry, this is also have 5 different ways to arrange that. So the total number of ways is 5 + 5, which is 10. Then we get the probability. We say, okay, so the probability equals the total number, the total, and the number. So here's the total number and the number of valid ones. The total number is clearly each one you have 2 choices, right? So 2 choice, 2, 2, 2, 2, 2. So that's 32. You just multiply them together by multiplication principle. And valid ones we calculate here, it's 10. This leads to 5/16, right? We just do caseworks and we find all those valid combinations. Method 2, we can further simplify this problem, use symmetry. Okay, now look, I have a negative one here. Well, negative is sometimes we don't want to handle negative. Well, because if you put a negative and a plus in front of number 1, there's no real difference in terms of probability. So that means the probability is the same as the following. I have 5 ones, right? And then you say, okay, I just put a plus or minus, plus or minus, plus or minus, plus minus, plus minus to be divisible by 3. Then we know there's only 2 choices. Either you just get 3 or you get -3. The advantage of this one, this part is similar. You just get 3 or -3. But if we look at the problem from this perspective, this one is easier because we get 3. It's the same. You get 3 plus -1, and this -1, -1, -1, -1 +1. Now you just need to decide which one you are going to put -1, right? All the others you put plus, and this one you just need to decide which one you put to be +1, and the others you all put to be a -1. Then we just quickly get the number. There are 5 choices because there are 5 positions. You choose one to put 1, and the second one is choose one, put positive 1, right? So this you choose one, put -1, all the others +1. And this one is you choose one to be positive, and all the other you put the negative in front of it. Okay, so again, so this is also 5, and you quickly get 10. So I think the method 2, and then you just get the probability for this one, again, is 32, 10, which is 5/16. Now the point is the method 2, I think it's simpler because we just need to handle positive numbers. Now, of course, the assignment of this one and this one is not the same, but what I'm saying is the probability is the same. Now, of course, like if you don't like this, you want to go with the straightforward way, then you just go with the method 1. You do caseworks, then figure out, you can figure out there are 5 different ways to put a plus or minus, and this one also 5 different ways. Okay. Here are the main step of simplification is here. The first one is, let's look at this. The first 2 steps of simplifications. Number 1, right? Because 3 and 6, they are both divisible by 3, so we can just get rid of them. They don't matter, right? Whether you put a plus or minus in front of them, simply doesn't matter. And step 2 is 5, we replace 2, 4, 5, 7 by remainders when they are divided by 3. Especially we use negative numbers, -1, because they're just smaller, easier to handle. And these are 2 major simplifications to solve this problem.